Hello everyone, this is Ali Reza. In this video, we will implement our sequence node. Now, if you search online for behavior tree on C#, you will find few different public repositories. And if you look at them for example, sequence node, you will see that they are looping through every child, ticking all of them, and then decide what to do. That is wrong. That is really, really, really wrong. I can't tell you how wrong it is. By definition, sequence node will tick one child per tick. If he ticks all his children and all his children return success, that is when the sequence node will return success. But the moment one of these children return failure, it will break the loop, and by the loop I mean between the ticks. It will break it, it will immediately return failure. So a sequence node will sequence one child per tick. This is important, okay? The moment one of the children returns failure, it will return failure. But if the child returns success, and he is still, the sequence node still has more children, he will go on, he will go forward, he will tick the rest of the children. The moment all the children were ticked, and all the children will return success, that is when the sequence node will return success. So that's the theory behind the sequence node, okay? Now I'm fairly sure that implementing the sequence node using enumerators is a valid solution, but unfortunately I'm not that familiar with that. And from my experience with games, for example, let me see if I have this game open. Yeah, I have it. Good. This is a game I play. Guys, whoever said that I don't develop games, meh, I'm developing games. I'm Itachi. This game, as you see, is commercial. You can get golds, you can get blah, blah, blah. And yeah, I have 900 golds in your face. Anyway, it has this demigod hero. It was added new to the game, and it was the source of tons of bugs, tons of glitches. This game lost many players just because of the bugs inside this game. Okay, why did I show you this other than proving that I'm developing game for them? That's just a game, I don't care. But the reason I showed it to you is that if you are not 100% sure what you are doing, especially on your very base systems, like a behavior tree, stick to the solutions that you are sure that would work. Otherwise, debugging a bug would be a headache, and trust me, there are hundreds of thousands of people that are sitting there in every game server just waiting to find one of your bugs to exploit and reuse it for their advantages, to gain benefits against the other players and to ruin your business. So that is why I didn't go with the enumerator solution, and I chose the very basic way of doing it because I'm sure this way is working. Okay? Also, another reason is that behavior trees, take a look at my setting on my agent right now, 0. But normally, you would tick your behavior trees like 1,000 times per frame or even 100 times per frame, okay? So that is important to remember. Everything that you do should be as optimized as possible here. We are not talking about preemptive optimizations. No, we are talking about real optimizations that need to be done right now. Okay? Because think about it. You are ticking each behavior tree 100 times per, not update, but per second, I would say. And then you would have 30, 50 agents in the scene. Each one have its own behavior tree, okay? So imagine, I lost the calculation, maybe 50,000 ticks per second. So even a nanosecond of optimization on a speed is important here, okay? So this may look like a really simple chapter to you, but in reality we are talking about artificial intelligence for our agents in future. Every bit of optimization needs to be there right now. That being said, let's start. Now under nodes, we will have another namespace and composites. That is a name that academies gave to few nodes. I don't know why, I didn't research it, but I'm stick to academics. So composites, zits, I don't know how to pronounce that. So here we will have our BT sequence node. The BT sequence node, of course, is a node attribute, and it inherits from, what did I do? Not that. BT base node. Here we will have a class BT sequence node schema. It's a node attribute, and it is a BT base node schema. Well, of course, I could differentiate this attribute for something like node schema. That would make the reading of the code better, but then I had to, you know, say, hey, add range this attribute to this. We will handle that at the end of the videos, okay? So, again, get ready for a copy paste for the help. That's it. That's our schema. So we set the icon, we show the name as sequence, and the help. You can pause the video and type it. That's exactly what I said at the start of the video. The only extra bit is that if it's negate mode and it was success, it will return failure, and vice versa. Okay? So that's our schema. Now, the node itself. We have a serialized field that is a private int index. Here I could maybe go with byte. I don't see any sequence node having more than 255 children. If you have it, well, you are doing something derpy, really, really derpy. To do, see if byte would do for the index, for the later on stuff. Now, we have methods to override. One is tick and one is reset. You may notice I'm not overriding initialize, because in initialize I have an input, I have an output, and that's okay for a sequence node. Okay? So, in here, after calling the base, we say index equals 0. As simple as that. Okay? Now, here is the real headache for me. We are doing this base at the very end. Here, first of all, we say if outputs dot is null or empty, or outputs dot connection, why are you not showing? Outputs 0, sorry, dot connection node dot is null or empty. It means that we didn't connect this guy to anything. So we set our lower state to error. A sequence without anything means error. We return base dot tick. Now, I should mention this. This line of code is completely designing Aishu. I decided myself that if a sequence node has no children, it means that the designer did something really derpy. That sequence node has no place to be in the graph, so it will error to inform him, okay? But you may decide to set it as success. If this sequence has nothing, then it's immediately succeeded. I don't see it as a valid solution. I want it to be errored. Then we check if index is greater than or equal to our outputs at index 0 dot connection node dot count, meaning that we already exhausted all our children. So it means that all our children returned success. This is when we return success ourselves. Okay? So we say var last child equals to outputs of 0 dot connection node at outputs of 0 dot connection nodes dot count -1, because we are 0 based. Now that we have the child, we say state equals to last child, that's a state. Now I could immediately, instead of this line, go for a success. And talking about optimization, I think that's what I would do, because we know that well, no, actually, the reason I have it, now that I think about it, last child may return failure, and the way I'm handling it, no, actually, I'm immediately returning. So this is not optimized. We say state equals to success. Okay? So after that, what we do, well, I have this line, type it with me, but we will comment it. Parent graph that active node equals to inputs of 0 dot connection node 0, comment it. And then we will have last child, and we don't have, no, that's not again needed, but there is reasons that I had these guys here, but last child dot ticked equals true. I'm not sure why I had them, because you know my R&D was going through iterations, and sometimes I had these problems. So a base that ticked, return base that tick. We will keep these commented because I'm not really sure if that will fix everything. So yeah, import the namespace for me. Thank you. Node child. Now here we say if check possible running child. Oops. Then we want to set the child equals to parent graph dot active node, because remember this check possible running child is setting the active node here. Okay? So we got our child, we say index equals to outputs of 0 dot connection nodes dot index of that child, and we add to it 1. So we increment our index now. Okay? Else child equals to the outputs of index 0, not 90, 0, dot connection node at index, and this is again index plus plus. So we add to index, okay? Now that we have the child, we say var child state equals to child.tick. Now we tick the child actually, okay? And we say child dot ticked equals true. This is why I commented this line. Okay? I saw that I'm ticking the child here, so why do bother with that? Now we need to decide about systems that can happen. So what can be the result of the child? The child can't return inactive. That's for sure. The child can return error, success, failure, or running. Well, the easiest one is the error. So if child state equals to error, we do stuff. We say our state equals to child state, so we errored out and return base dot tick. Remember, we don't return the state directly. We always return the base. Although, if you look at this, we are just ticking ourselves, returning ourselves, and then checking the state. But that is important. I could have this part in every one, and I didn't like it, so I put it in base. And now we always return the base to check for that error state. Okay? Now that we had done that, we say if our state equals to success, if for whatever reason we already are in the success, we say parent graph.active node, again that commented line. So let me copy it. In my notes, I was setting the active node to the parent. I'm not sure if I should do that. Then we say return base.tick. Now we have three more conditions to fill. One, the child returned failure. That's our early exit, remember? So we say if child state equals to failure. This is when we do few things. We say state equals to failure. And I had that commented line, and we return base.tick. Okay? So we return. We fail, we return. If child state equals to success, now what? Now we need to check our index. If index is greater than or equal to our outputs dot outputs 0 dot connection node dot count. So if we are greater than or equal to that, we already exhausted our children. The last child was success, so we say state equals to success. We say I have a very buggy line here. I see the potential errors here. 0.state equals to our state. Why am I doing it? I don't know. Then we had that parent graph and return base.tick. And I will tell you what was wrong at the end, because I don't want to, make your brain explode with details. So, if we are not exhausted all our children, what now? We say state equals to running. We didn't finish. We are in running mode. We say parent graph dot active node equals to this. So we need to be ticked in the next tick, and return base dot tick. Okay, I hope it makes sense. If we are not exhausted all our children, we still have more job to do, so we are running. The next tick, we want to be the node that we will tick by the graph, so we set the active node to ourselves, and we return the base. Now, at the end, I have this part again. So if we reach here, for some reason, none of these guys happened. Oh, wait, I missed something. Sorry, if child state, and I was worrying where was the running. If it's running, what now? Well, we set our state to be running, but we are not setting ourselves as the active one, okay? Like the one before. We have a child that is running. We want it to be the running one. So we return just the base dot tick. Okay? Now, if we are here, we just set ourselves to success and return. And of course, if nothing happened, if we shouldn't reach this line, honestly. This line is just there so that the method don't yell at me that you don't have anything there. And that is our sequence node. Let's build it. I hope these commented lines would fix some of the issues I had seen in my R&D. Let's come back. Now let's go nuts. We don't have it. Okay. So remember in our behavior tree schema, we had these guys. So I will copy this. I will paste it here. And I will directly put it here. I'm not going for composites because composites of the most nodes that you will use. So sequence directly here and bt sequence build. Come back. So you have our sequence. Let's create it. This is our very first sequence. Let's go nuts. Remember, normally as your very first child of the start node, you will either have a sequence or a selector or a random combination of this. I mean, a random sequence or a random selector or a sequence or a selector. I never had seen anyone having anything other than this. Oh, look at here. Null reference. What was the null reference now? Node line AT. That was not what I was expecting. Wow. Where's the node? Line AT. Huh. Whoa. Child.inputs. Well, of course, child is null. So we say if child equals null. Well, this is not. Wait a second. dot not null or empty. Build. Wow, I know. Oh, where is my start node? Delete. See, this is what happens every now and then. So a sequence node, and if I connect it now it's connecting, okay? So sequence, and basically the code was the same. It's one of those points that I should have deleted the graph beforehand and recreated the graph beforehand. I don't know. So connect, 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 and connect. Now is where that success node comes handy, you know. We want to sequentially get success. No, what? Okay, you came by yourself. Let's go nuts. As I said, sequence node is one of those nodes that gave me the most headache. That is why I'm heavily testing this node. So that and I will put these two down just because. No space. And finally, one more, please. Thank you. Now, let's reset the graph and let's tick it ourselves one by one. So, running, running, running. This is success, but I don't get that stuff. So, running, still, that guy got success, and this guy is not getting success. This should get success. So, let's uncomment lines one by one. First of all, I need this line and this line. Let's build. Ticked, and I don't see that tick graph anyway, and I'm not going up. Okay, so wait a minute. Okay, so let's unpand which one. Well, let's track our state first. This guy is 29D blah. Okay, so now let's find what the. Oh god damn it, no. My naming is wrong. Okay, ID. There we go, 29D5. Okay, so let's tick it. It's running, still running, and in running. Okay, so actually I was looking at this guy, ULA. I wanted that one. That's the one. Okay, reset the graph. Tick. Now it's running. Now it succeeded, and you see that index is equals to 2, but it's not going up. I mean, it's not setting the state of the parent. So let's take a look. The child state is success. The index is that. State equals success. Yes. Okay. These two lines need to be there. So we are setting our parent's state, and we are setting that as the active node next. Okay. Actually, I wonder if I put this only. That's not the correct way to set the parent state from within ourselves. We just need to set it as the active one. So there we go. But now it's not going up. So this one was that 29D blah. Okay. And reset and tick. Tick, tick. So we get the success, but we are not passing it up. Okay. So when the state equals success, yeah, this line. And of course, when we are failure, that's the thing. So the only thing that I was really bugging is this line, because I had seen bugs like this. I was setting my parent when I shouldn't set the parent. Okay, so that's that, and the state is here. Okay, build, reset, there we go. So now the only thing remaining is that why I don't see that graph stuff, and I think it was in here. No, actually, where is that Dragui? Oh, wait a second. Delete node, initial setup, add toolbar items, add menu items. That's it. Okay, that's correct. Base node schema. That's where I'm drawing the GUI. Node skin null, base, negate, negate. That's okay. So now we go back to our graph, node schema GUI. Compare it to my nodes. Notes, not nodes. Okay. That's the icon, view rect. Okay, okay. Check additional style. Okay, I'm fairly sure this is the problem. I'm just setting the style based on this. Now, interesting. I had that. I'm fairly sure I had that stuff somewhere. Let me check my other nodes, because I have two different iterations, and my schema on behavior tree. No, my schema on the nodes. Yeah, here we go. Okay. I was fairly sure that I was running something. Okay, so after we check for the null, before calling the base, we say if parent graph dot related graph dot active node equals to our related node GUI dot box new rect of node boundary dot x minus 2 node boundary dot y minus 2 node boundary dot width plus 4 node boundary dot height plus 4 no words node skin dot get style. The style we want is node current. That's that. Copy these, paste it, and we say if parent graph, no, actually, if related node, I wonder why it's not in my notes, related node that ticked, then the style that we want is node ticked. Okay, build it. Coming back, you should see a yellow line behind the start node. Let's tick it. Now you see that this guy was ticked. This guy was ticked. This guy was ticked. But which one is the active node? So that is because I forgot something. I forgot an else here. Build. Going back. So here we go. Now we know that this guy was ticked down here. Then it set this guy as active. See how handy it is? So this guy was ticked down to here, and this is active. Now this guy was ticked. This guy was ticked. Now this guy is active. Going back up, it ticked and returned success. This guy is active. And so on and so forth. Now, you may say, hey, and here's why I had some stupid notes here and there. If you look, right now, if I tick, I'm successful. The graph is not successful yet. It needs an extra tick until the graph itself becomes success. And by the way, let me debug that node names. Why are you... Wow, I screwed something here. So, then here, utils, graph utils, graph name equals name. Okay. But that's not what I want. It's here somewhere. Subname, that name. Node name substring that. Okay, where I'm creating the node inside the toolbar. No, not in the toolbar, in workview. So graph, editor, view, workview. And here is the bulk of it. So this is the graph plus the node. That's correct. So for example, in case of a start node, that's the one. But in case of, I don't know, a sequence, this node name would be BT. That's correct. Why are you setting everything so derpy? Delete the graph, yes. Create a graph. That. In case of a start node, that's okay. That's working. Success. You get this? And wait a minute, where is our success node now? Oh, wow. That's why. So, coming back to my notes, very old notes, but let me see on create node. Okay, we initialize the node. We add it. Then we say parent graph equals that. Add object to asset, current node to schema graph.related graph. Okay. Let's double check our editor stuff. That's totally wrong, you know. Maybe it's initialize on the start node. I screwed something somewhere. I'm fairly sure about it. Let's take a look. Start node to related graph. Schema to the graph. Well, that's the correct one. And we can confirm that's the correct one by deleting these guys, creating a graph. You will see that the start node is the child of behavior tree schema. And the start node is the child of the tree. So when I'm creating another node, here is the problem. Let's track it. Okay, that's okay, that's okay. We get the namespace, current node equals that. Then if it's null, through that. Then subname plus node, initialize, add. Okay. Add object, current node to the related graph, save asset. Up to this point, is everything okay? That's okay. That's okay. Then we set the name to subname node schema. Related node equals current node. Initialize, setting the positions. That is selected true. We add it to there. Current node schema to schema graph. Yeah, everything is okay. Everything is okay. The only thing that comes to my mind, no, actually, well, let's try it. Let's hide this part. Build. Coming back. And decorator success. So wow, that's stupid. And of course we don't have it here. Okay, that's okay. But let's try it. I don't know what's wrong here. I'm getting the node name, okay? Yeah. Then current node equals to cast to node, descriptable, create instance, get type node name, namespace. If current node equals null, return. In this case we have thrown. Namespace node name substring 0, node name length -4, node name subname, name equals subname plus space node, initialize. I'm not doing anything derpy here, do I? No. I just have this that is set to false. That's okay. So yeah, I'm not doing anything derpy here. So after that we say schema graph, related graph, nodes, add current node dot parent graph, schema graph, related graph, asset database, add object to asset, current node to schema graph, related graph. Then save asset database. That's okay. I will stop video. I will debug this issue and I will come up with the solution in the next video. Have fun everyone. Bye bye.